Okay, so this video is going to cover the other two examples from the notes that we did not get to in class. On example 7, it is already one fraction. It is already less than or equal to 0, so those two steps are already taken care of. What we have to do is we have to consider, when is the numerator equal to 0? It's a constant, so it's never equal to 0. When is the denominator equal to 0? Well, when x minus 1 is equal to 0, that would be x equals 1. That would be an excluded value. I'm already regretting drawing that in blue. Fortunately, technology exists to let me fix that issue. So, let's get that fixed. That should be in red. Alright, so when we go to do our sign chart, if it'll let me here, there we go. When we go to do our sign chart, there's only one value on that sign chart. That is the excluded value of 1. There are no zeros for this function, so we don't have to worry about that. We go in, we check a value on each side of 1, starting with 0. Plug in 0 to that function, you get 1 over negative 1 squared, which is 1 over 1, which is a positive number. Everything below 1 is positive. Pick a number greater than 1, say, I don't know, how about 2? And we plug that in, that is 1 over 2 minus 1 quantity squared, which is 1 over 1 is also positive, which means on both sides the entire graph exists above the x-axis. Then we need to go in here and we ask ourselves the very simple question, when is the graph less than or equal to 0? Well, that would be negative, and the answer would be it is never negative or equal to 0, so that is a no solution. On to example 8. Fortunately for us, this is already a fraction. So all we need to do is figure out its zeros. We ask ourselves, when is x squared equal to 0? Well, that would be when x equals 0. So we have 1 0. Then we ask ourselves, where is the denominator, which I'm about 1,000% certain is supposed to be an x squared. When is the denominator equal to 0? Well, x squared plus 4x plus 4 equals 0 is factorable into 2x plus 2's, meaning we have x plus 2 squared, which gives us an excluded value of negative 2. Now the multiplicity of both of these things is 2, which is going to affect our sign chart. So we go into the sign chart. Again, we fixed this typo here. We made this x squared. We have an excluded value of negative 2 to consider, and we have a 0 at 0. We are going to be picking one value from each interval. So a value less than negative 2, doesn't matter what value we pick. How about negative 10? Negative 10 squared is 100, so the top is positive. On the bottom, we would have 100 minus 40 plus 4, which is still positive. A positive divided by a positive is a positive, so that entire section of graph exists above the axis. Then we pick a number between negative 2 and 0. How about negative 1? Negative 1 squared is positive 1, so the top is positive. The bottom would be positive 1 minus 4 plus 4, which is also positive. So a positive divided by a positive, guess what? That's still a positive. And then we plug in 1. 1 squared is 1, so the top is positive. On the bottom, 1 squared plus 4, that's positive 9. So positive over positive, that whole section is also positive. So the graph is greater than 0 in several places here, but not everywhere. Despite popular belief, it is not positive everywhere. It is positive from negative infinity to negative 2. Negative 2 is not in the domain, so it's not at negative 2. Then from negative 2 to 0, but 0 is not negative or positive. 0 is 0, so that's not included. And then from 0 to positive infinity. So when we write this out in interval notation, this piece here is written as negative infinity to negative 2, not including negative 2. The piece in between is written as negative 2 to 0, and the piece above is written as 0 to infinity. That does it for lesson 2-6b. Thank you very much for your time.